Okay, welcome. Wow, we got a full house tonight. We had a suspicion that strawberries and chocolate would attract a crowd, and here we are with a full house. So thank you so much for coming. Welcome to Fourm, breeding the best strawberries, and we always appreciate you guys showing up to these events and sitting to listen about the science, but also taste the food, which is the best thing. You put the science with the food and you have a wonderful experience, so we're looking forward to that tonight. I'm Ned Spang. I'm the director of the Robert Mondavi Institute and associate professor of food science and technology. I really do enjoy these forums to have discussions and bring people in. I love dealing with my students. I love my colleagues, but it's great to invite the public in for a lot of these events. It's always great to see some new faces. So for those of you who don't know, the mission of the Robert Mondavi Institute is actually to engage in discussions with the public on food and beverage, and thinking about specifically where we're innovating on food and beverage here at UC Davis. So we definitely are going to have that conversation tonight. We have a long history of innovation in strawberries here at UC Davis that has been a really incredible history. Our Forum series is specifically focused on research and scientific development. We have other engagements such as Savor, Taste, where we bring in vendors for different food. We invite people from outside campus to talk with a faculty member about some science and how it applies to decision making or industry. So we have a lot of opportunities for engagement. I invite you to check those out. But for tonight's program, we're focusing on the history of strawberries. As I said before, this is a 100-year legacy of strawberry breeding at UC Davis. And we're interested in understanding how plant breeders respond to evolving challenges so that we can support growers in the strawberry industry. We'll also taste 4 varieties of strawberries tonight, which is going to be really fun. And you guys actually get a chance to vote on which strawberry you like the best with those QR codes in front of you. Tonight's lecture will be recorded. We are going to have questions and answers at the end. Also, at the end, we are going to have more strawberry tasting with chocolate out in the foyer. I want to thank our friends at Guittard Chocolate for coming and donating a tremendous amount of chocolate for you guys all to eat. As well as chocolate curtains that have provided the chocolate fountains that you can dip your strawberries in. So we're all looking forward to that. But first, the science. So it's my pleasure to introduce Dr. Stephen Knapp. He is Distinguished Professor and Director of the Strawberry Breeding Program in the Department of Plant Sciences here at UC Davis. He's an expert on plant breeding, quantitative genetics, and genomics. His current research focuses on strawberries, with emphases on developing high-yielding, disease-resistant cultivars, breeding and genetics of fruit quality and shelf life traits, and the application of genome-informed breeding approaches. He was previously Global Director of Vegetable Breeding Technology at Semenis, Professor and Georgia Research Alliance Eminent Scholar and Graduate Program Coordinator in the Institute of Plant Breeding, Genetics, and Genomics at the University of Georgia, and Professor and Paul C. Berger Endowed Chair at Oregon State University. He teaches qualitative genetics here at UC Davis and previously taught advanced plant breeding and quantitative genetics at OSU. Thanks so much for coming tonight, and I'll turn it over to you to introduce the rest of the panel. Thank you so much.
I know you're all anxious to get to the strawberries, so I'll try and make it semi-quick here. We are celebrating a centennial here. I hired this guy 10 years ago. I was very lucky. I started working with him. Well, it's a long time ago. Anyway, it was before genetics was invented, but I was very fortunate to that our paths were able to cross. We worked on sunflower together. He was a breeder at Pioneer Hybrid, and I was in academia trying to get it going. So we've been back as a partnership the last 10 years here, UC Davis. So of this 100 years, we're the last 10. And the future's sitting here too. Mitchell Feldman, who's in the back's my successor, and Allison Krill Brown, right back there, is Glenn's successor. And we're going to keep Cindy forever. She's down at Salinas. Wave your hand, Cindy Lopez. The 64 pounds of fruit that's hidden in the back, Cindy hauled from the farms of Naturipe, and you'll be hearing from Hillary Thomas soon. So I just want to tell you, it's a very weird plant. It's a hybrid between 2 wild species that grow in the New World, but it became a hybrid in the Old World. And the story goes, spies from France collected plants from Chile, took them back, but there were plants also being brought from North America to France. And they arose as hybrids in the Trianon And I just want, this is a reminder for me to also look at my wife who's back here, Shereen Knapp. In 40 years, she's never, well, she's heard me talk. She's never heard me give a talk, and I think this is, which is really remarkable. So thanks for hanging in there all that time. Yeah. But we're, just ironically, we're going there this fall too, so it's just very cool. But this arose there, but the thing that's even more amazing about it is a 19-year-old discovered this origin before genetics was invented. Can you imagine? A 19-year-old, when I was 19 years old, I was just hoping I didn't wreck or go to, you know, in a ditch somewhere. But this guy was discovering how this plant originated. And so basically, once that discovery was made, the domestication started. The reason that's kind of cool is if you think about something like wheat or rice, it's been domesticated for 10,000 years. So we have a really brisk 250-year domestication process going on. So the strawberries you see in markets today are completely different from what existed 250 years ago. And I think we're going to learn from Hillary and from Glenn also that certainly the last 50 years have been profound in terms of the change in what's happened to strawberry and what this crop has become. But it's really, you know, 300 years is a very short period of time. UC Davis has released we've had a lot of outstanding scientists that have gone before us, and they've released 72 cultivars since 1924. And many of those have become very iconic, but one of the impacts you can't see is that genetics has gone around the world, and it's used in breeding programs around the world. So you'll find the ancestry of this material almost everywhere you look at strawberries. This UC Surfline, one of the newest short day cultivar that we released this year. And so we've released 12 since 2015. And I think they're getting more exciting now than the cultivars because we've had a chance to really start to put some things together that weren't present, and I hope the tasting will provide a hint to that. I'm going to turn this over to Hillary. She has a great perspective about where the industry's been, and what we want to do is provide you with a real snapshot of what's happened since, say, the 1950s to now. And so let me turn my mic on and let you start. How's that?
Okay, this works? You can hear me? Okay. Yep. Okay, well, it's really a treat to be here. Thank you so much. I'm a UC Davis alum, and I'm a UC Berkeley alum, and now I'm a long-standing member of the strawberry industry. And so I just want to take this part because I just want to give a little bit of context of the history of this partnership between the public breeding program, the University of California, and the strawberry industry, because it really does highlight the history of innovation in California agriculture and how, you know, research-driven public programs can partner with businesses and with really savvy businessmen to kind of have mutual benefit and good positive outcomes for everybody. So I was looking through some of our pictures, our very old pictures. Naturipe Berry Growers is who I work for now, but I've worked with most of the industry over the time I've been down there, since I moved down there from Davis. And so we were founded in 1917, and this was founded as a marketing cooperative of growers. So growers came together, they wanted to come have a label. But what these pictures really highlight for me, and something that maybe people don't understand, is back in the day, they were trying to use genetics that were from the East Coast that didn't perform well under California conditions. It was much drier. There were a lot of insect pests. I'm an entomologist, so a lot of insect and disease issues that were out of context for these cultivars. And back then, you had a very short window, so we were dealing with what we call June bearers or short day varieties, and I think Steve's going to unpack all of that for you. And so everything was, you know, the idea that you could take this perishable fruit that only the affluent had access to, that had this very short harvest window, and then make it accessible to the average household in the United States was not possible at that time. When we were founded, it became quite popular. So by 1920, there were 250 growers. We were called Central Coast or Central Coast Berry Co-op. And that was like 95% of the growers that were down there at the time. Most of them were Japanese Americans. Those are the people who really were able to take the time and effort, or committed their time and effort to make this work, because it was very hard to get all these variables together. and have a positive outcome. To the layman's eye, the picture below, which is what strawberry fields look like now, it's a little fuzzy here, looks quite similar, but there's been a huge number of differences that have happened in optimizing our production systems so that we can open up the fresh market. So the war happened, 1945 ended the war, but Japanese growers were mainly interned during that time. And so the industry, I wanted to point out some of these key things that just fortuitously happened. The war ends, the public breeding program moved from Berkeley. So this, I think you know, that this used to be the university farm for Berkeley. And this wasn't even a campus when they moved the breeding program up here. So you guys probably know more than I do. It's been a couple years. But during that time after the war, there was really very little money in California. And so the growers kind of begged the university and begged the state to put more money into the breeding program. And they got that in 1952. And the breeder at the time, Richard Baker, I'm not going to talk about the whole history of the breeders, but switched at that time. And so a breeder named Roy Springhurst started working with a technician who'd already been there named Victor Voth. And this, it's not to idealize them, but what we got was the marriage of really good breeding, really, good strategies around breeding to horticulture and agronomic backgrounds. And so what came from that was that now California, out of these 4 very rural counties, is supplying 90% of the nation's fruit. And so I think it's this beautiful story where this is the premier breeding program. You're talking to the guy who's taken it to the next level, right? But this industry is also, we've opened the door, and that happened through all of these innovations that Steve's going to talk about, the advent of day neutrality, this idea that we could have even production along season in these cool coastal regions, right? Combined with, we were able to raise the beds up. Some of that was just having tractors that were powerful enough to raise the beds up. And so that made it easier to pick the berries. And they did all this work with planting times and to optimize this crop. Vernalization, the idea that you could add chill hours. These are all things that came out of the University of California's partnership with the industry. So we're very lucky. We were very lucky then, and we're very lucky now. And where we've ended up is that we have, still 60% of our varieties are public cultivars grown out of that came out of the University of California program. I don't want to talk too long, but I do want to point out that what we're growing right now for where you typically think of as a fall planted program, so what you're growing in the Watsonville Salinas area, the northernmost production area, is mainly cultivar Monterey. And that was released in 2008. And then what we're growing on what we call a summer plant is Portola. And so there's things that need to be improved. We're ready for a replacement cultivar, and you're going to taste some of those today. I'm really excited to see what the feedback is on that. What we need as an industry right now, we have these prolific yielders, right? We have these varieties that are really good. We need to maintain that because our cost of production, our cost of growing and labor for this, we're still a hand-harvested crop, has doubled. And we have that, right? I think that's something that you'll speak to. We need to maintain the post-harvest qualities. So we weren't able to ship fruit. This was largely a freezer market back in the day. So only for local distribution. And so the ability to move fruit is what allowed us to, have a bigger market. Things we're looking for are plant architecture. So that, we've tried very hard. We've invested hundreds of millions of dollars in trying to mechanize this, but it's just not possible with such a soft fruit. So some of the cultivars that you'll be tasting today are ones that make that plant architecture much smaller while still maintaining the yield volumes that we need to be profitable. But most importantly, none of that matters if the varieties don't have the disease profile that we need. And that ultimately is going to come down to the breeding that these guys have done and the improvements that they've made. And then flavor. I think we all, right? Steve's going to explain to you what some of the trade-offs were that got us to where we have this industry. And I think these are all things that he's doing very well with. So I think back to you.
Yeah,
turn my mic back on. I promise you're not going to put up with me much longer here. I'm going to turn it over to Glenn. Just think about the volume going from almost nothing in 1960, right, to this calculation's just mind-boggling to me. 383 billion individual fruit harvested in our state every year. That's a lot. I mean, there's more around the globe, but if you start thinking about just the sheer number of fruit that are produced and moved to marketplace, it's incredible. And it had a high demand in terms of what was needed. Mitchell, who's back here, and I worked really hard on a paper. We called it the manuscript review process from hell, excuse my language. But it described this green revolution. Glenn's a co-author along with Dominique Pancot from our lab. And what we had looked at in the UN data, which was really shocking to us, is that the yield in the US has gone up 2,800% since 1960. That's phenomenal amount of yield increase. But Europe had stayed flat, and that was really baffling to us, and it prompted us to study this a little bit further. But the ultimate thing I wanted to point out here is that Europe and the US moved the same in terms of production increase over that period. So this has been accomplished in California through the production improvements and the genetic improvements that have occurred. There's a lot of science behind this, but this just shows you the gain in 3 traits, and we've really looked we inherited this in 2015 to understand where have we been, how did we get here, and where do we go next. And it was really 3 traits: yield, weight, and firmness of the fruit were key to creating this export industry. And so this just shows an almost entire history of strawberry domestication. Those arrows point to what the modern cultivars are today that make that 90%. So just to give you an idea. But those are astonishing numbers. I'm going to tell you about 2 genes that it wasn't just 2 genes that made it happen, but I wanted to first proudly say, it's the only academic slide you're going to get from me. But when we came in 2015, the strawberry genome wasn't sequenced, and one of our proudest achievements was getting the first genome out. Now they're all over the place. It's just like you can get your own genome, you know. But I just wanted to point out to you why strawberries are so great. They have 4 times the genes we have. Yeah, 100,008 genes. Why do humans only need 25,000? I don't know. Strawberries much better. But this is a depiction of just 8 of those 28 chromosomes there, and there's 30,000 genes represented in just that fraction of the strawberry genome. That's the equivalent of chimpanzees, humans, tomatoes, a whole bunch of plants. So we feel like we're better for that reason. Okay, but it's really 2 genes drove a lot of this gain, which is fascinating to look back. It's not that simple. But this is Royce Bringhurst, who in 1953 came. He actually survived the war. He was a bomber pilot, a very interesting history. And he was in the Wasatch Mountains and collected this plant. And this plant was the source of a gene called perpetual flowering. And that gene was moved into the cultivars that were available at the time. This is Glenn holding one of those legacy materials that we keep out in our collection there. It's from 1965. And you can see the size of those fruit. So he's moving from a wild plant into this wonderful fruit we have today. This was a game-changing gene. When they published this work, and when Hillary and I talked about this today, when he first published this and came out, he said, you know, these things just have almost no future, but the home gardeners may like them. And this gene by itself ended up transforming the industry. And so this is Glenn standing in a field of, I think it's Royal Royce. And what we have shown is that gene enabled a doubling of yield. Think of that one gene. Now there's a lot more behind it, but that's one gene. And you know, I told Glenn, look, we don't need more yield. So what did he do? He went out and selected a plant that's 54% higher yielding. I don't know how anybody does that. I think it's magic or voodoo. But this is one of the cultivars you're going to taste today. But we're really proud of this. But these yield gains have been astonishing to us. It's unheard of in plant breeding, really. And this cultivar has been tested in lots of different farms, and we still have high yields. But we need more from these plants. We need better flavor and other attributes. They're all firm. And I just want to talk about the other game-changing gene. It's a polygalacturonase. Mitchell and I met with the student today in his dissertation committee. Nicolas Jimenez, a student from Chile, is graduating, by the way, in a couple of weeks. And he's been studying this gene, and this one gene doubled firmness. And so if you look at this slide where it says short shelf life, that was what you had in the 60s and in a lot of the early fruit. And as this gene was moved into material here at UC Davis, the fruit became firm and it could be shipped. And that really adds up to something important: reduced perishability, reduced spoilage. So I usually start with this in talks, scientific talks, which is what happened to flavor. Don't blame me. But this had to emerge this way to be able to produce that many fruit, 383 billion fruit, that get moved, packed and moved. And so it's really about trying to create a product that arrives in your grocery shelves at all times of the year, right, in a decent way. So what Glenn's going to be talking about, we're really trying to now move the program into a different direction of, not just great shelf life and yield, but bringing in more and more traits. But all these things came together to create really long shelf life and high marketable yields year round. There are lower months than others, but California is usually producing something almost every month. I am going to shift gears and let Glenn take over, and he's going to tell you about some of the real specific traits we've been working on, and then I'll close with just a couple comments at the end.
Thanks, Steve. So looking at the slide there, you can see again the influence that UC cultivars have. They're all over the world, and breeding programs from all over the world have used them. But we license these. We have an international licensee that licenses our varieties throughout the world, and we're getting more and more that want our strawberries. And there's places we have patent laws and we have to protect our germplasm, but there's places that don't have those vehicles in place to do that, countries in the world, and they're all eager to get our materials. And so and part of it is because of Steve and the lab and all the science that has been created. They've been reading papers and they want access to the germplasm because of that. So, excuse me, I've been out eating too many strawberries today. So it's a big deal. So the industry is more than just the berries. I mean, so we supply the varieties, and they're sold by nurseries. So there's a nursery business part of this, and it's a component that we have to select for, because you can come with a variety, and we're working on traits. You clonally produce strawberries with clones, runners, and they have to runner. And if they don't runner really well, you can have a great variety and it doesn't runner very well, like we did with UCD Moxie that we released a few years ago. Wonderful variety, but didn't runner. And the nurseries didn't really like it because they can't produce it and they can't make money. So we got to keep those guys happy, right? They got to make money, and so we have to select for things that have runners. And so if you ever happen to be driving on 97 from Weed, California, to Klamath Falls, and you go through there at night, and you'll see this glow of lights, because all of our plants in California are grown in the high elevation, and Hillary commented on it about this, the value of vernalization of these plants. They produce better when you grow them in high elevations and they get all these chilling hours. And so the industry has moved towards harvesting these things at night because they get a better quality plant, they get better chills. And so there's a million plants that are produced up there every year. And a lot of that goes to California. A billion, I'm sorry. Yeah, geez, what? A billion plants, that's right. And, and that's not all for California. A lot of that is exported into Mexico and into other countries. And so that's something that's really important for us. We have to manage our breeding program to make sure that we're keeping that end of the business happy. So go ahead. And so we run our nurseries up there, so all the materials that go into our trials, we do trials up and down the state, and we just had a field day yesterday in Lompoc. And we do, there's 3 main regions: Oxnard region, the Santa Maria Lompoc region, and the Watsonville region. And so we have to generate plants. We generate all of our plants that we put into our trials, and we plant them up in the high elevation. And so lot of numbers we're looking, it's a breeding program. You have to look at a lot of numbers to be successful. And so we do our nurseries up in that environment so that we can produce the plants that go into our testing system. Likewise, we have a wonderful Wolfskill Ranch in Winters, California. If you've ever driven on Poudre Creek Road, you might drive by it and see a bunch of olive trees. Well, in that fence is where we have all of our germplasm. We have to maintain that germplasm. It's a clone, so it's not like we can go put it in the seed packet and bring it back out. We have to maintain those plants, and we have about 1,000 things that we have to maintain, 1,000, 2,000 things that we maintain every year. And every year we're replenishing that supply with new selections. And so, you have to select the right things you're gonna keep and throw away. I will point out that really, so here you can see the difference in runner production, something that produces less and something that's amazing and produces tons. I will say, one of my hobbies is going out and collecting strawberries or wild crops. Used to be sunflower, now it's strawberries. That was collected at Stevens Pass, right off the eastern part of Mount Shasta. And there's a subspecies of, and the reason I collected it was because it was a subspecies that didn't occur in the collection at the USDA. And now we're working with it, and I told Steve last year that one of the grandparents of this is in a cross that's 50% higher yielding than Eclipse. We don't need more yield, I know. But so anyways, but it's unique genetics, and it also has played into identifying genes that play into a disease story. So we'll go to the next. And that's what we're dealing with. And so we haven't talked about, some of the tools that the industry, the previous breeders didn't have to worry about diseases as much as because they had some tools. Methyl bromide was the tool that they had, and it was a wonderful, amazing tool to clean up the soils, no diseases, no weeds, and they could breed for yield. And now we have to breed for diseases because those tools are going away. Methyl bromide has gone for the berry production farmers, and we have other tools that we currently use for fumigation, and they may go away. And so it's been, as Steve and I came on, that was our main strategy, was to, go after disease resistance, go after the genetics of disease resistance, and the incorporation of that into our breeding program. So this is a picture, just real quickly. This is from Hillary's world of Watsonville, and that's a field that's just destroyed with Fusarium and Macrophromina. So next slide. And this is a picture of a field near Lompoc. Those white beds that look like they should have plants, well, they did have plants, but they all died. And this actually is an organic production field, so we have more and more organic acres. Organic acres don't fumigate, period. And so they need disease resistance. And, those were two varieties that we released, and they were wonderful varieties. They were released to replace Portola, which was a big component of the bar pie chart that Hillary showed, that lots of acres of Portola, and but it tastes horrible. And everybody wants to replace it. And so we released these two dead varieties here, Finn and Mojo. They didn't have Fusarium resistance. We knew it. The growers wanted it. We did it. And then, amazingly, our new one, right next to it, that's alive right here, that's Eclipse. And you'll get to taste some Eclipse. And that's the one that Steve had talked about as wonderful yield. It has Fusarium resistance. Why do we have that resistance in our program? Well, we identified through the work of our team and Dominique Pinco, we identified the resistance gene. We then created a tool so that us breeders can go work with it and make things and breed fast for the resistance. Now all of the germplasm that we test has Fusarium resistance because of that marker. And so those two products died because our partner who was testing the materials like Eclipse saw that thing coming and said, we're not growing that Finn and Mojo, we're waiting for Eclipse. And so we've just released it, and they're excited about it coming. So it's more than just Fusarium, though. I say with that Fusarium field, was kind of virgin ground, and it was planted to strawberries. A lot of organic production goes into virgin ground. Why did it have Fusarium? You know, so some of these diseases exist more ubiquitously than we think. And macrophamina is a perfect example of that. Macrophamina attacks all kinds of crops. Used to attack sunflower, and I used to work on it, and I couldn't find resistance for it. Well, we started with a similar story here in strawberry. The A box up there you're looking at, we took, you know, 1,000 things that we had in our collection of broad genetic diversity, and we went and screened it for resistance, and about, 98% of it? So say there, 98% of everything we tested died completely. And we had a few things that were resistant, but it wasn't like they were like amazing. There was a very few things that were amazing. So we took some of those things and made some crosses, and we quickly started shifting that level of resistance, and to 2 cycles of selection and intercrossing of materials, we've now totally shifted that resistance curve to having really good resistance. What's more amazing about this disease is that, generally speaking, it's usually very quantitative and really hard to breed for. Well, we have people like Steve and a whole lab of students who figured out, we've got like 10 genes, and we just published. We've identified 10 genes that are involved in, if you put those things together, you get better resistance and better and better. And now we're working on, well, what are the best 10? Out of those 10, what are the best ones? Because we know one that was really strong that helped us shift this curve was also one that was resistant to flowering and having fruit and yield. And so, and so we're working with that kind of stuff. And so, you know, now we're working to make the mix. We're blending those genes to figure out what's the best ones that keep the yield, the production for the growers, and maintain the disease resistance that we need. So anyways, we're really proud of that work. And so flavor. We don't want to forget about flavor. We got a lot to experience here shortly, hopefully. So, you know, that's a perfect picture. A lot of what we have to do is we have to breed for really pretty strawberries. And, you know, so, you know, when people go to the store, they look at it, and that's why they're in clear clamshells, so they can see it and look. But one of the things that we've identified, you know, I go to Costco, and you watch people in Costco, and they go up to the clamshell, and they look at it, and they go, oh, there's Driscoll's over there, or there's Naturipe over here. And then they look at it, and they go, oh, it looks really pretty. Then they click it open and they sniff it. Naturipe smells really good because they got Monarch over there, or hope to soon. So next slide. So we went after what are some of the factors that go into flavor, and it's more than just sugar and acid. That's the simple stuff. Well, it's not simple. The unfortunate piece is that yield and sugar are negatively correlated. And we got a lot of really high yielding stuff, like Steve said, you know, how do we get back to the flavor piece? And so as you move that needle, you know, you go select all those things that are really sweet, that they don't yield. One of the ones that a lot of people may know in here, Albion, was a really game changer for the UC program. Wonderful flavor. We still test it, put it in our trials as a flavor reference, but it don't yield. It's terrible. And so some of the other things that we have to work on besides just sugar and acid are the aroma compounds. Getting back to that Costco customer and the sniffing of those varieties in the market. And so likewise to sugar and acids, the aroma compounds, and there's a lot of them, can be easily impacted by the firmness and the yields that we have in our varieties. And so, go ahead, next slide. So there's actually about 350 aroma compounds that you could experience. How do you differentiate 350 things, right? Well, you can't. Or no, there are experts. I mean, we're in a sensory theater. There are some people that are amazing. But there are probably about 4 or 5 main things that we are targeting, and they are the strongest components. And I can talk to you about some of the uniqueness of each one of the varieties that we have. So I've been working with Allison this year as we work through our seedling selections, and it's a lot of bending over, it's a lot of sniffing, and a lot of tasting, actually. So Allison has helped me now. So actually, Allison's been doing a lot more bending over and sniffing and tasting than I have, and I'm taking the notes, but it's been great having her. And so there's a lot of work that goes into that. And so we're hoping, and the other thing I want to say is, because I tend to talk too much, is we went into a lot of older genetics to go after all these flavor profiles that exist. And it's a lot of really weird genetics, and it's a lot of soft genetics, a lot of no-yield genetics, it's a lot of small berry genetics and soft berries. And so Steve and I decided to go after these unique things. And there are unique flavors that come from around the world that we wanted to try to integrate and then get into the new things coming. So now, as we hand off the program, Mitchell and Allison will have a plethora of these things floating around in the program, and they're gonna try to work through those things, maintaining the yield, disease resistance, and all that other stuff that we've got. So we're pretty excited about that. It's great. Steve's been great with bringing in all these students. Mitchell was a student in our lab, and now he's going to be a successor. And we've had a lot of people working on the different traits that we're working on, developing the genetic tools that we use, and it's been really fun. And now there's a whole new level, a whole new group as Mitchell takes over and bringing in new people. And so we're excited about where the path is going, and we're gonna taste some strawberry, I think.
Or pretty soon, yeah. Can you still hear me? Yeah. So I think I put this slide in. Ned, it shouldn't be a mystery that at a university one of our jobs is to train people, but that wasn't the history of the program, actually. And so one of the really exciting things for us, the new cultivars are great and all the science, but the people element of this has just been so important. And we have, I think, 6, soon 7 of our trainees who ended up in academic industry positions working on small fruits, which is incredible, actually, at Reich Swan, at the USDA. And so it's been a really important part. This is just a small sample of those people. And I just can't tell you how much it's meant to me. It's kept me younger, sort of, working with these young people. My brain cannot keep up with them now. They recognize that too. So, what's beautiful now is that as we came through COVID and we knew the transition was going to occur, is we got the succession plan in place, and the lab has been really reinfused with undergraduate and graduate students and brought that energy, and I think as we came out of COVID, it was like, oh no, COVID, retirement, all that happening at once. But it just, the vibrancy now, I think, in the group is really tremendous, and there's a lot to look forward to. I have to say this, just that one other thing we're really proud of, and I'll close here, and then I promise we're going to taste. Babette and Jamie, someone's going to help with the logistics. We're really proud of our collaborations, and Mitchell's carrying many of these forward, with whether it's with biotech vendors, with collaborators in Europe, other parts of the world. Also, the huge piece of this is this program could not survive without the industry. And so, making this slide up, it's like the RV with all the bumper stickers, where have I been? And I'm looking at it and I'm going, okay, I got to remember, what did I do with, But just to give you an idea, just one little line there, Mitchell's been involved in the development of 4 genotyping platforms for strawberry. Maybe it's 5. But those things have been, it's 5. Those things have been really game-changing. And so I just wanted to really thank everybody publicly that's made that happen on both sides of the equation. And we are going to stop now. And we're going to taste strawberries, I promise, and there's going to be chocolate. We're ready, and they're going to bring them into you in trays. And you're going to score these for us, right? Yeah, okay. It'll be fun. The floor is open too, I guess, while they're doing that, if you want to ask questions or start to have a discussion. Yeah. Oh, sorry. Yeah.
Hi, this was utterly fascinating. So thank you all for putting on this event. I got several questions, but I'll just stick with one. I'm wondering, of all the traits you mentioned, resistance to changing climate was not one of them. I'm wondering if you could speak a little bit about that.
Yeah, that's a really interesting one. So Macrorhamina, in fact, is associated with climate change in high temperatures and drought and heat stress. So one of the things we've really experienced, and one of the really beautiful things about this Macrorhamina story, there's a very dark what I'll say, the literature on Macrorhamina resistance in plants is terrible. I mean, people have had a lot of failures. So as this was unfolding, Glenn would say, you got to come out to the field and see this. And I would go, no, I can't believe it. Something went wrong. But this is definitely associated with climate change. And the breakthrough for us was him realizing that heat and drought stress were necessary to get the genotypic separation. So our first instinct was that, I'm just giving you an example, but I think what you're going to see is that climate change will profoundly affect the regions in which strawberry are produced, and definitely will impact a lot of these diseases that are conflated with abiotic stress, right? Anything that weakens the plant makes a plant, especially a necrotrophic pathogen like this, loves weakness. So if you weaken the plant, it'll really attack.
One of the other things that farmers are having to deal with and are addressing is salt tolerances. And part of that is because of where a lot of this is grown. It's grown near the coast where there is saltwater intrusion in the aquifers, but also, there's a lot of salts go into the ground because of the nitrogen and everything that's being used, and there's going to be limitations for farmers on the management of all that. And so one of the things that we've been able to capture as we do our trials is we've been identifying things that have salt resistance. So the things that win in our trial are those things that have that. So that's another one that we're dealing with.
Thank you. That was just fascinating. I've learned so much. You spoke about cross-pollination and cross-breeding, but you didn't go more specifically in the techniques. Are you using modern techniques of genetic engineering, CRISPR and things like that, or are you using traditional last century methods? And do you feel any constraints?
Yeah. Great question. Who are you first? We have a list of questions we knew we'd always get, right? Let me think about how to do this. We're embracing, and we have a wonderful collaboration with the scientist Juan DeBernardi in the Plant Transformation Lab. Mitchell and the team are working with, there's several genes right now that we're trying to understand, and we're using CRISPR gene editing to knock them out and to just understand their function. We feel like these tools have to be available for the next generation. These problems are too big to just rely on the natural variation. But right now, all of our breeding effort is natural genetic variation. There's no genetic engineering going on. If there is a genetic engineering experiment, it's really to upregulate a gene to see how it works. It's all contained. It's not going out into the world. We gave a forum a couple years ago at the California Strawberry Commission on gene editing, and had a wonderful Marta Bjornsson from our lab, a wonderful scientist, project scientist, and Juan did that. And there's a really strong debate about whether this can be adopted in our industry.
If you will accept it, we will accept it.
It's if the consumers reject it, it destroys all their organic and other production. So one of the ironies for me about this whole story is, I probably shouldn't even go here, but we get letters of support for our grants, and we had phenomenal letters the last 5 or 6 years for our grants. And one of them that I was really proud of is the organic community wrote really strong letters for us. when we put this new grant in that now Mitchell's taking that over, we worked on it together during transition. We put gene editing in there because we had to be able to address the problems we're working on. We have to be able to do this, and we're also competing at the national level with the top science. And the organic community came back and said, "We love your proposal, but we're no longer supporting you because you're doing gene editing." And so I tried to have a healthy debate with them about it and saying, well, this will benefit your community more than any other community, and talked about the safety, but it was a non-starter. So we encounter this a lot where we're trying to talk about what technology can do in a healthy way, but it's a tough conversation, and I understand the toughness of it. I also buy organic, and I'm not hung up on it, but I'm like a lot of the Davis community. I'm at the farmers market buying organic food because I care about it.
I have a question. Actually, I have two questions. My first question is a very basic one. Is that the whiteness of the flesh of the strawberry, does that indicate ripeness?
No, that's varietal.
And my second question is, you mentioned something about a lot of the crops being grown on virgin ground. Does that mean never before cultivated for agriculture, or never just grown strawberries?
Never grown strawberries. Right.
You could have organic ground in vegetables for 20 years, never have strawberries, and go on with strawberries. And so what's been discovered is these diseases are much more widespread than people understood. And so there's a lot of that ground is infected, so you've got to really have the protection. There's also one other thing, the anthocyanin, the pigments in the fruit itself. A lot of the genetics we brought in from the Pacific Northwest are processing berries. We used to go to the U-Pick place when we were in Oregon doing that. They're very intense internal color. They also are highly perishable. But so we have some new cultivars in the pipeline coming that have a much more intense red core in them. And they have a unique flavor also. There's a uniqueness to them. In fact, I was trying to push for high antioxidant strawberry, and what we discovered is those really high antioxidant strawberries taste really terrible. So I kind of abandoned, I was thinking, oh, high antioxidants, that's a great thing, but every time, we have some that are just like dark, almost purple, and they're horrible tasting, actually, unfortunately. Yes. Oh, sorry.
Okay, thank you.
I'm here because the strawberry I knew as a kid is gone, dead. And now I'm sitting here eating these strawberries, and I want to know, since I'm 80 years old, is my smell gone wacko? And are you taking that into account? Or are you taking the fact that as you age, your taste goes kind of wacko?
Yeah, the strawberry you had as a kid is the same one I had as a kid. It was available 2 weeks of the year. My grandmother picked it. We got 2 pints and we were done. And everybody goes, oh, now next year, in upstate New York or Vermont, we'll have strawberries next June again, So there's a lot of those fruit are there. We have, Glenn talked about the collection of 1,000 genotypes we have out at Wolfsco. We have tons of those old heirloom cultivars. There's no reason they couldn't be produced. They're hard to produce. They're hard for people to grow and bring to the market. They're perishable.
Do you want to comment on your aromatics work, though?
Yeah, well, so the part of what we're really trying to achieve is aromatic enhanced flavor. Because we think even with this longer shelf life material that we can enhance the aromatics substantially, and that'll improve that part of it.
I think in the meantime that chocolate used as a flavor cover-up is sort of cultural.
Well, I don't think that's ever failed.
She's ready for next generation.
Yeah, chocolate. I don't think chocolate has never been a problem with improving the flavor of strawberries. from everything I know. Yes, sir.
I wanted to ask about the possible confounding effect of what at least for myself and maybe some other folks, my perception of the flavor of strawberry was very largely and perhaps unfortunately influenced by strawberry soda and other artificial flavors. How does that affect when you're dealing with tastings and people come up, it's like, well, it should taste like strawberry soda. It's like, no, it shouldn't. Or should it? I don't know. What are your thoughts?
For me, there's sort of the quintessential strawberry, but the one and I know you're going to hear the sound of this compound and think, I don't want to eat anything that has it in it, but I love strawberries that have high gamma-decalactone, but it's the peachy compound. But people perceive these in different ways, and thank goodness we have Allison now, because if Glenn's doing all the smell and taste selection, we'd have like 10% of the community covered, and that's one thing we find is that people react very differently to the aromas and sweetness and acid, so there's a really broad differences in what people perceive, but I have no idea what strawberry soda tastes like. I don't know.
What is the most common homegrown variety that's or sold in the market or planted now?
Chandler is one that's available in most of the farmers markets, and we have a wonderful project with the Small Farm Advisor, Margaret Lloyd, excuse me, we have a brain freeze here, to try and move some new cultivars into the local production. She works with the Hmong growers and others, but they still grow Chandler, which has been around a long time. And a lot of times that's what I seek out at the stand out there off of Covell and a couple of these others, but yeah, Chandler. There's some really iconic cultivars that have hung around too. Early Glow has hung around for years. It's really wonderful. And Albion, which was mentioned earlier. But you don't see much of that at the farmer's market for some reason. Don't know why.
Do you grow strawberries at home? Are you looking for variety?
Well, the co-op sells the most antiquated, I don't know where they're getting these strawberry plants, but I'm looking at them and going, well, there's something from 1942. That'll work pretty well, Well, you know what I mean? They just find, I don't know, they just get them from somewhere, but there's a lot of wonderful cultivars available that people, but plant availability is a real problem in strawberry. It's for the small growers here, it is, and for home gardeners it is. But Johnny Selected Seed has a good selection and a couple other small companies.
I would make the recommendation if you're going to buy, I just went through this thought exercise the other day. If you're trying to do it at home, all the varieties that are going to be marketed to you are going to be really tasty, and so pick what you want, right? But if it were me, a lot of this middleman stuff where it's already potted, or
right.
I would want to look online for somebody who also has on their website that they do commercial bare root, because you're going to get a really high quality nursery plant.
Right,
What Glenn
that's
was
it.
talking about, the quality of our nursery plants, and then you're going to have a well cold conditioned plant that's going to establish, it's going to push what we call runners or stolen stems, and then you're going to be able to set those as daughters the way we used to way back in the day. You'll get your established strawberry patch, but my recommendation would be if you really care about the flavor, you might have that short window strawberry like a Mar de Bois or something like that. But if you can kind of be a little bit more compromised on flavor, but you want to share and have a longer season, pick a cultivar that's grown here in California that's now available. Pick an Albion or something like that. It used to be the standard. It's super tasty. It doesn't have enough volumes for us to make money. But if I had to grow at home, if any grower you ask or any nurseryman you ask, that's what they grow.
We had New Hampshire, colleagues at the University of New Hampshire who acquired new cultivars, and we got a message, Glenn and I were shocked. They said the New Hampshire farmers, they're growing for the farmers market there, love these new UC varieties that are actually commercial here on the coast. Well, the way they were growing them and ripening them, the flavor was fabulous, and they had very low wastage. So a lot of it is, there's a lot of good cultivars out there. It's just the plant health is critical.
The biggest thing that this team did, instead of having one site where they bred, they made us farm it. I mean, these are the strawberries you taste today are from my field, I think.
Yeah, they are.
Yeah, okay. But no, what I'm trying to say is a strawberry that's grown in California is going to perform well in California. Like this gene times environment thing is really important, and Steve's made us grow it for him in so many different environments. So,
Wide area testing.
Yeah, what's the sweet spot when the strawberry is picked, when you should just get rid of it, when it goes bad? Are we talking days, weeks?
Get it as fast as possible and buy more.
I'm not adding any footnotes to that.
But if you're looking, the other day I saw the promotional news article that came out of Florida Strawberry Growers Association is pretty good at telling you how to store them, what to do with them. But they say the same thing, 3 or 4 days. You try and eat them as fast as possible.
Some of those I showed, we have some medium shelf life or shorter shelf life. Those are more the market garden. Those are going to perish faster, but you're going to be producing them locally and distributing them locally. So, you probably have that same window of time.
Quick question. It seems like it's time to educate the consumer and put the variety name on the plastic box.
Oh, boy. We've had, we've had a million conversations about this, and go ahead, Hillary. That's
So we can't grow all of these varieties all the time. And now we're at a place, right, where you want to buy you want to buy strawberries year round. When Portola is in production, we plant it in this late spring, early summer to fill this market niche where there's not a lot of production in California, fall planted varieties, or Mexico, or Florida yet, right? And so there's this gap in like September, October that's really hard to fill. And so that market will tolerate that poorer flavor, right? So from my standpoint, the reason why we don't do that, like Europe does, right? If you're in the UK or like Gerald was just in the UK, they'll market, but it's not traveling very far, if that makes sense. And so the problem that we have is in order to feed, but now that the household penetration is so high, right? I mean, a lot of people, it's not rich people who are buying strawberries. It's actually a lot of young people. It's a lot of people who care about nutrition, this younger generation. That's what the newest kind of surveys say. And so to make that accessible, affordable, and year-round, that's why we don't market by variety, ultimately, is because we can't guarantee that we can get you the variety that you want.
I think that's part of it, but as there's more local production, I don't understand why at the farmer's market, for example, there aren't named varieties there brought, because that should be an easy thing to do. That's not, packaged big ship thing. So it'd be wonderful to have that sort of clarity. Then you could go ask for Eclipse or Monarch or what have you. Yeah.
Hello.
Oh, hi.
My father was very active in the program in the 60s, the Brasiero program. And I was wondering, could you talk a little bit about who's doing all this very labor-intensive harvesting of the crops today? So and also the payment of those people.
The hot topics, right? So it's true. That is still very labor intensive, right? And we've really tried to get away from that. There's been huge efforts to do that, but it's just hard to pick. It's not even hard to pick the strawberry. It's hard to compete with the talent of a worker picking a strawberry, to be honest. Robots can't do it as well. And when humans perform well, robots perform well. But I will say, yes, the Brasiero program, at the end of the day, 60% of our strawberry growing operations and affiliated companies are Latino-owned. That's where we're at. All of the companies, though. So like any industry, you have people from the pickers to the transportation, supply chain, logistics, and the growers. The growers, we're 65% Latino community. That's the reality. Well, we have lots of housing crises throughout California, yeah. I'm with you. I feel it.
I have two questions. One is, in the west of France, there is a variety called Guittard.
No, this one, very well.
I was wondering if it's related to one of these here. That's one question. And the other one is, we have what we call fraises des bois, which are wild strawberry that we find in the woods. And they are incredibly fragrant. And I was wondering if there's something you could look at and maybe, hybrid.
We have a lot of work in this area, and so I know Guittard very well. That one slide you saw was me, and my wife knows this, me tasting strawberries from every farmer's market, every town we went in for a month in France, and tasted all the cultivars. Very familiar. We have a big effort to improve the flavor aroma of the mainstream strawberries. So maybe soon you'll have something like this, but you got to realize those are produced on a smaller scale, in a local scale, and there's no reason that couldn't be done here, right? If there was an interest in that type of fruit, a grower here could grow it and bring it to market in a local market sense, right? So those all exist. The genetics isn't gone. It's just what people grow. And as far as the Mardabois, the Fragaria vesca, woodland strawberry, I'm not a big fan, but we eat it all the time. And what he put in front of you is?
All right, we got time for one more question right here, and then we'll go and you guys can find these guys and ask additional questions in the reception.
Sorry, it's back here. It's right behind me. Well, I'm flattered. I'm Sam. I'm a PhD. Is this on? Better? PhD student in agricultural economics, studying organic strawberries. Okay. So I'm actually curious about a question related to the lady up front regarding labor. So as the farm picking labor is growing older and technological picking is, although still a failure, but probably going to improve in the next few decades. Do you see any increase in the potential use of tabletops in?
So I've done a lot of tabletop production. I actually did the first substrate production in the state with 6 different growers. It was chaos. I think there is some tabletop production in Santa Maria. You're the ag economist. You run the numbers. I've done the P&L. It doesn't pencil. It just doesn't pencil at this point in time. It's close. I can get it close. Oh, so sorry. Tabletop production is not growing in the soil on these beds that you saw. It's essentially, and it's done in a lot of other regions. No, it's more like a rain gutter, like the gutter in your house, raised up. Actually, I had a picture, but I think we took it out, of one of these varieties in tabletop. These varieties perform quite well in tabletop. And so the idea, right, is could you move to a region and also use different labor, right? Because different people, it's a much nicer job to stand and walk and pick something that's at the perfect height for you. The problem is the economics, right? Getting that to work. So you can get higher volumes. You actually can get higher quality fruit. You can get larger fruit. But the cost of the systems that you have to have in play, you just can't even amortize that stuff over a long period of time to get it down to where you're in business. There are big moves on controlled environment, particularly on the East Coast, right? All this ideas that you could have a plant factory in New Jersey where there's all these big warehouses. But I think if you really spend some time tracking those companies and their funding, and it dries up because you want to be standalone. You have to be standalone profitable, and they just haven't been able to work. And the carbon from it. So this is another thing we're really butting up against is sustainability. And at the end of the day, it's not. You can get to lower water use and you can get to lower nitrogen use and inputs. But the whole system, the energy, even the energy use of the system is higher. So when you crunch all those numbers into a carbon footprint, it's problematic at best.
See a lot more soilless and bench type production in Western
The
Europe.
big driver for that is disease and to get higher quality jobs onto the farm. Those are the kind of 2 big drivers for looking at those systems.
Before we let you guys go back into the foyer, we're going to go back to analog technology. We had the QR codes, but we're just going to have people raise hands. Do you want to lead the vote here?
Oh no, we're going to do a clapping because we're very anxious.
For your favorite strawberry type.
I know the team up there who works very hard on this. They're anxious to know. So I'm going to say the name and clap if it's your favorite, and we're going to go through all 4, and then we'll figure out who has the majority. So I'm going to start with, let's go alphabetically, actually. So I'm going to start with Eclipse.
Okay.
Golden Gate. Yay. We like that because it's a small plant and it's really fast to pick. So thank you. Keystone.
Okay.
I told you.
Yeah.
Monarch.
Monarch Golden Gate. Yeah.
Thank you.
Or there, it sounds like a tie.
Monarch Golden Gate, yeah.
All right, well, thank you guys for your great questions. I definitely want to thank the panel. So Glenn, Steve, Hillary, thank you so much. We of course always love to get your feedback. So also on your sheet of paper is a second QR code. If you just want to tell us about the overall experience of the evening, we'd love to hear from you.